Okay, boys and girls, today we're going to finish up our journey of simplifying radicals with our last train stop of dealing with adding and subtracting radicals. So last week we talked about how to deal with simplifying radicals, and today we are going to discuss how to deal with adding and subtracting radicals. So in order to do that, we're going to go back and just refresh some things about adding and subtracting like terms. It's kind of a little bit like combining like terms. There are a couple extra steps, but a lot of those extra steps you'll deal with in the future. But let's just focus now on adding and combining like terms. So here we have a problem, 3x plus 4x plus x. Now we've talked about in here when you add and subtract like terms, you want to find items that have the same caboose. So when you look at this problem, the coefficient is 3, but the caboose is x. The coefficient is 4, but the caboose is x. Here there's no engine out front, but we know that engine is a 1. But again, it has a caboose of x. So if they all have the same caboose, we can add or subtract them. So once you do that, you just add the big numbers out front or the coefficients. So 3 plus 4 plus 1 is in fact 8x. Okay, take a look at the second example here. I have 2xy plus 4x plus 5xy plus 6x. So again, we want to focus on their cabooses. So here I have an xy. Well, over here I have an xy. So they have the same caboose, so I'm going to be able to combine them. Where here I have an x, that's different than an xy. I cannot combine them with the xy, but it can go with the other train that has a similar caboose there. So I'm actually going to put 2 underlines there. So the things that I combined have to have the same caboose. So 2xy plus 5xy becomes a 7xy. And then combine the other similar caboose, 4x plus 6x, becomes a plus 10x. So again, a little bit of review of combining like terms. And then finally, let's look at the last example here. 4ab minus 6a minus 6ab plus 2a. So again, let's underline and identify the items with the same caboose. So there I've got an AB, nothing with an A. Here I've got an AB. So those two guys have the same caboose. What else? The 6a and the 2a. So those guys I can combine because they have the same caboose. And again, you're going to see why we're doing this once we go through a few examples in a couple minutes. So focus on what I can combine. Well, I can combine the ABs. So 4AB minus 6AB. And notice you always look in front of the number for its sign. So 4 minus 6 is a negative 2. So it's going to be negative 2AB. Now combine the A's. Well, that's negative 6. Remember, look in front of the number. Plus 2. Well, negative 6 plus 2 is a negative 4a. And this is as far as I can take it because, again, they have different cabooses. So I can't combine them any further. That's just our final answer right now. So now let's speed ahead to today's lesson on simplifying radicals using addition and subtraction. So we're going to use the same process of combining like terms. They have to have the same caboose in order to add or subtract them. Okay, so what we're going to do is look at page 89. Hopefully you printed it out. And we're going to go through about 5 or 6 examples here. Okay, so let's first take a look at the first one, which actually is one of the more difficult ones. So first thing I notice is I've got some radical signs. I've got 2x cubed and 2x cubed. So before I do anything, I want to simplify what's inside the radical sign. And we did this last week, so let's just quickly review. So I'm just going to rewrite this as 4. Now 2 I can't do anything with, but x to the third's got an odd exponent. We've already learned that you break that up, make it an even, turn that into a 1. Plus 3, do the next one. So that's square root of 2 x squared times x. Now when you look at this problem, the only items that can escape, the 2 can escape, not a perfect square. X squared can escape, it's got an even exponent, and x to the first cannot escape. So I'll circle what can escape. That can escape. And just as a review, when it escapes, you divide the exponent by 2. So really these now simplify to 4x square root of 2x because these guys have to stay inside. They were not able to escape. Plus 3x square root of 2x. So now let's take a look at this. Do they have the same caboose? Well, 4x has a caboose of the square root of 2x. 3x has a caboose of square root of 2x. They have the same caboose, so now I can add this. So I would add 4x plus 3x, and 4x plus 3x is 7x with the same caboose. Okay, so that one's kind of one of the more difficult ones. Just try to bear with me as we go through some of these if you are stuck. Okay, take a look at number 2. Now, number 2 is a little bit easier. So let's first take a look at the cabooses. So inside the radical sign is the square root of 2y. Well, 2 is not a perfect square, and y can't escape the radical symbol. Same thing over here, 2y. So they are taken as far as they can. Now, let's take a look at the cabooses. The cabooses are actually the same, so that's good news. I can then combine them. So they are combining with addition. So all I'm going to do is now take the number out front, 3 plus 2 is 5, times the same caboose. Well, the caboose doesn't change, it stays square root of 2y. So that one wasn't bad. Not a whole lot of work there. Okay, let's move on, take a look at number 3. So, first thing I notice is I do have a perfect square inside my radical symbols, here and here. These two guys in the middle, inside the radical sign, I cannot simplify them any further. They're as far as they can go, so they're going to stay like that. But I'm going to deal with this guy first. I know 4 gets to escape. I know 4 gets to escape. So the square root of 4 is 2. So that's going to be 2 times 2 on the outside. So that turns into 4 times the square root of x, because the 4 goes away, plus 3. That stays. Can't do anything with that. That stays. And then finally, this last guy, the 4 gets to escape, so it becomes a 2. So 4 times 2 is 8. So plus 8 times the square root of x. Okay, the x's have to stay inside the radical symbol because they can't escape. So now look and see what you can combine. Well, here I have a square root of x, here I have a square root of x, same caboose. Here I've got square root of 2x, here I've got square root of 2x, same caboose. So combine the items of like terms. Okay, well, again, always look in front of the number. So this is 4 plus 8. So 4 plus 8 is 12. Use that same caboose. And then on the inside, it's 3 minus 2. Well, 3 minus 2 is 1. So that's going to be plus 1 square root of 2x. Now, this is as far as I can take it because square root of x and square root of 2x are not the same caboose. So this would be your final answer for number 3. Okay, moving on. Let's take a look at number 9. So number 9, I have to do a little bit of work. This is kind of combining what we talked about yesterday. So at this point, all the cabooses are different, but they can be simplified further. So let's go ahead and work on simplifying these further and see what happens after we do that. So take a look at the first one, square root of 50. Okay, I know that can be broken down. I've seen this before. It can be broken down into 2 times the square root of 2 times 25. And there's my magical perfect square. Minus 4 times the square root of 4 times 2. And there again is another perfect square. Minus 3 times the square root of, and that's going to be 36 times 2. So again, here's my perfect square, here's my perfect square, here's my perfect square. I can circle those because those guys are going to escape. Oops, circled the wrong one there. Let me go back. Circle that guy. So they're going to get to escape. The 2's unfortunately will not escape. So let's go ahead and make sure that they escape now. So square root of 25 is 5. So 2 times 5 is 10 times the square root of 2. Minus the square root of 4 is 2. So 4 times 2 is 8 times the square root of 2. And then finally the square root of 36 is 6. Well, that's going to be minus 3 times 6 is 18 times the square root of 2. So now let's look and see what the radical symbols are. Are they all the same caboose? Well, there's square root of 2, square root of 2, square root of 2. They all have the same caboose, so let's go ahead and combine those. So that's going to be, again, always look in front of the number. 10 minus 8. 10 minus 8 is 2. 2 minus 18. Well, 2 minus 18 is actually a negative 16 times the square root of 2. So again, just to quickly review, simplify what's inside the radical symbol, see if you get any perfect squares that can escape. These guys were able to escape. That changes the coefficient out in front. And then combine the items with the like terms. Okay, take a look at 13, kind of similar here. Okay, I want to break down what's going on inside the radical symbol. At this time, they do not have the same caboose, so I can't do anything with, but let's see what happens after I break down the radical symbol. So that's going to be x times, well, let's see here, 27, break that down into 9 and 3. There's my perfect square, plus x, and I'm going to break that down into 4 times 3. So now I have items that can escape, and just put them out front once you take the square root. So that's going to be, the square root of 9 is 3, so that's 3x. The square root of 3 has to stay inside. It was not able to escape. And the next one, the square root of 4 is 2, so that gets to escape. And when we do that, we now notice we've got the same caboose, square root of 3 and square root of 3. So that means I can combine these like terms, so it's going to be 3x plus 2x, which is 5x times the square root of 3. Okay, let's move on down to 14. Now, 14, we notice that the cabooses are the same to start with, but just to get into practice of simplifying your radical signs, I'm going to simplify these guys first. So, to do that, I got an odd exponent, so that becomes x squared times x, minus 4, again, same thing, x squared times x. So all I did was break down the x to the third power into items that can now escape. So this x squared can escape. It's got an even exponent. So the square root of x squared is just x. Remember, divide that exponent by 2. So that's going to be 3x times the square root of x minus 4x, because that x squared gets to escape, times the square root of x. And then notice I now have my similar cabooses. So 3x minus 4x is negative x times the square root of x. So that would be your final answer there. Okay. And last one we're going to do together here is number 19. So again, I've got right now 2 items that are not the same caboose. 24y and 54y are not the same, so I can't do anything with this. But I can, again, use some of my math to manipulate the radical symbol to see if I can get something that does match up caboose-wise. So let's first focus on 24y, so that I can break that down into, let's do 6 times 4 times y, plus 54, I can break down into, oops, forgot my 3 out front, break down into 9 times 6y. So now I've got perfect squares in both these guys, so I'm going to circle my perfect squares. That guy gets to escape, and 9 gets to escape. The other items can't escape. They're going to stay inside the symbol, as we learned last week. So now let's do the escaping. And when you take 4 and escape, so what's the square root of 4? Well, the square root of 4 is 2. So you multiply that by the number out front. So 5 times 2 becomes 10. And whatever's not circled remains inside the symbol. Plus, well, what gets to escape over here? The 9 gets to escape. What's the square root of 9? Well, the square root of 9 is 3. So that's going to be multiplied by the number out front. So 3 times 3 is 9. And again, whatever's not circled has to remain inside the radical sign because they are not perfect squares and can't escape. So now we notice we have the same caboose, 6y, 6y. So just add 10 plus 9. 10 plus 9 is 19 times the square root of 6y. Okay, so that's going to be your final answer there. So again, when you're doing these problems, just take your time. Try to break down the radical symbol if it can be broken down into perfect squares to get them to escape. And then identify what has the same caboose that you can add or subtract. And as always, if you have any questions, please log in office hours for Mr. Como or myself. And as well, you could always email us too. So again, you can always go back and rewatch the video. Just as a reminder, please do not do problems 5, 18, and 20. So skip those problems. Do not do those on page 89. Okay, again, if you have any questions, please feel free to contact us. Good luck.